approximate roots or approximate solutions to a given function. There are so many ways you can do it. Among which is the method of linear interpolation, the interval bisecting method, and the Newton-Raphson method. In this lesson, we are going to focus on the Newton-Raphson method. The Newton-Raphson method says that if f of x equal to 0 has a solution in the interval a less than equal to x less than equal to b, where x0 is an initial approximation of one of the roots, then for different values of n, the other roots are obtained by this formula: xn plus 1 equal to xn minus f of xn all over f prime of xn. This means that for different values of n could be 0, 1, 2, and so on, you are going to get the next approximation until the number of approximation that the question wants you to find. So when n is 0, we are going to have x1 as the next approximation to x0, which if you substitute 0 here, you have x1, you put 0 here, x0 minus f of x0 all over f prime of x0. If you want the third root or approximation, you have when n is 1, you put 1 here, you're going to have 1 plus 1, which is 2, equal to, you have x1 minus f of x1 all over f prime of x1. This method, this means that and each of this is called an iteration. And so from this method, you see that each time you are going to be looking for an approximate root, you are going to make use of the previous approximation. If you are looking for x1, you are going to make use of x0. If you are looking for x2, you are going to make use of x1. You substitute here, here, and here, and then you simplify to get the solution. And it also means that this f prime represents the derivative of f of x. So to use the Newton-Raphson method, you must equally know how to find the derivative of the given function. Consider this example as we apply the question. Example, our function is given to us like this, with an initial approximation of negative 1.5. And since we are using the Newton-Raphson method, I first of all write down the formula that represents the iterations. And then looking at the formula, I know I need to find what? The derivative of f of x. So I find the derivative here. Then now, starting my iteration with n equal to 0, when n is equal to 0, I put 0 here. I have x1 equal to n is 0 and substitute 0, 0. So it gives me x0 minus f of x0 on f prime of x0. Now I already know x0. x0 is the initial approximation that was given. So what I need to find is f of x0 and f prime of x0 simply by substituting x0 in f of x and x0 in f prime of x. I do the substitution here for f of x. So I have f of x0 is equal to, I do the substitution, it gives me negative 4. I do the same substitution for f prime of x. It gives 30. Then I substitute now back in my x1 equal to this and simplify to have the answer of the first iteration correct to 2 decimal places as negative 1.37. But the question wants us to do 2 iterations. So we continue the procedure. When n is 1, we substitute 1 here, we have x2 is equal to x1 plus minus this. And again, we already have x1. x1 is what we had before. So we substitute here. We look for f of x1 and substitute, f prime of x1 and substitute, and then we simplify to get the answer this way correct to 2 decimal places, and which completes the solution of the problem. So this is how you apply the Newton-Raphson method to find approximated roots for any given function. Thank you.